So,
Okay, 70%. Does that, my probability for rain or my probability for not rain? That is my probability for rain. Now, I don't like percentages, y'all. In math problems, we don't use percentages. We gotta turn them into decimals. We got to woo-woo. So what am I gonna put in? 0.70. So that was possessed right there. Okay, so this was my 70% that I did my whoop-whoop on. Now, I'm out of numbers, y'all.
There's the other part that makes up the 100.
We're doing the not, we're doing the complement. So either you rain or you not rain, and that equals 100%. So if it rains 70% of the time, what is the not rain? 30%. That's how we're getting this number. Either you're pregnant or you're not pregnant. So this is going to give me my expected value. So if I go to my calculator, 21,000 times 70%, plus 60,000 times 0.30. This is how many people we should prepare for. This is how many people we should expect. This is what vendors do all the time. If they're doing an outside hippie fest and they're trying to decide how much food should we prepare for, how much stuff, what should we prepare, if there is a chance of rain, and they've done this in the past, they need to prepare and they need to set up. So we should expect 32,700 people to attend based on the weather forecast. Okay, let's look at another one. Let me get, hold on, I want to find one. I've got a specific one in my mind. Just going to use this one. Copy. Paste. And let me get our formula. Copy and paste. The directions say find the expected value. There's a 30% chance that I'm going to win $500 today. There's a 70% chance I'm going to lose $300 today. What is my expected value? What should I expect to happen? Okay? So, what are my events? Winning and losing. I have two events. It's not raining and shining. It's winning and losing. Either I'm going to win or I'm going to lose. So, my expected value is either I'm going to win or I'm going to lose. So, it's going to be value times probability plus value times probability. Okay? I have two values. I have a win value and I have a lose value. My value to win is $500. What is the probability that that's going to happen? 30% or 0.30 plus my lose value. Now, here is where I'm going to screw you up. Anytime. Build you up to tear you down. If you lose money, y'all, it is negative.
Yep.
If you make money, it's positive. If you lose money, it's negative. Times 0.70. So for this previous problem, it wasn't negative, we just had less people coming. We can't have negative people, we just have fewer people showing up because it's raining. But for this problem, You're winning a positive $500, but here you're losing money, so it's negative. So when I do this one, it's gonna be, I win a positive 500 or 500, and there's a 30% chance that that happens. Plus, negative 300 times 0.70. So, my expected value, so what should I expect, y'all?
$60.
I expect to lose $60. If that answer was positive, then I would expect to win money. But I'm expecting to lose money in this deal. Now, I want to go back and show you a real life, for those of you who actually do some, I don't want to say gambling, but some lottery stuff. This problem is a typical lottery problem. Now that we know a little bit about expected value. Suppose that you're buying a dollar lottery ticket. And these are the following probabilities. You have a 1 in 5 chance to win a free lottery ticket. A 1 in 100 chance to win a $5. A 1 in 1,000 chance to win $1,000. A 1 in 10 million chance to win $1 million. What should I expect buying a lottery ticket? Okay? Note, winners do not get back the dollar they spend on the ticket. So, expected value, remember, is value times probability plus value times probability plus value times probability for all the different instances. So for this one, we have a lot of what ifs. Number one, we have to buy a lottery ticket. My husband says all the time, Jen, if you won the lottery, which you're not going to because you don't play because you teach statistics, but if you did, you'll never quit your job. And I said, no, I love what I do. But if I ever won the lottery, I wouldn't quit my job. Love it. So, number one, you got to buy the lottery ticket. So, you're going to spend $1, and the probability of that happening is 100%. You got a whoop-whoop, that's 100%. So, I've got to spend $1, and the probability of that happening is 100%, because if I don't buy a lottery ticket, none of the rest of this is going to happen. So, the first thing is I'm going to buy a ticket. Plus, this event is for me to win a free ticket. So winning a free ticket, the probability of that happening is 1 in 5 chance. The probability of me winning $5, the probability is a 1 in 100 chance. The probability of winning $1,000 is a 1 in whatever, yeah, y'all got it. Plus, the probability of winning the jackpot of $1 million is 1 in 10,000 chance. So if I plug all of that into the calculator, that would give me my expected value. So if I come down here, and they did it in a chart, but I just plugged all of that into this calculator. So, my expected value is this. So for every $1 I hand over to the cashier at the gas station, I should expect to lose 64 cents. So y'all, if it was me, and I have people say, I just spend $1 a day. Well, y'all, that's $364 a year. And if you're losing 64 cents a day for 364 days a year, so if we do the math, 365 days a year, and we're losing 64 cents a day, then you just lost $233. So instead of spending $1 a day at the gas station and losing $233, spend that $1 a day putting it in a piggy bank. Then at the end of 365 days, you have $365. reality. This is why Ms. Cooper doesn't play the lottery. So, this is saying if you bought 1,000 tickets. So if I did 1,000 tickets, oops, 64, I would expect to lose, out of 1,000 tickets, I would expect to lose $640. So playing $1 here and $1 there adds up. And it becomes real. I mean, that's a lot of money. $1 a day. A couple of dollars here, a couple of dollars there. So that's the law of large numbers. The one that I'm going to give you is nothing harder than what you're doing right here. Either it's going to rain or it's not going to rain. Either I'm going to lose money or... Example of test question. Cool. Who would have thought? So, that is pretty, I mean, I'm going to do a little bit more in 7-3, or 6-3. I will do a little bit more, but as far as the test is concerned, I've taught you what's on the test for 6-3, but I will do a little bit more 6-3, and then we'll go into 6-4. I'll see you at the lotto in the gas station.